welcome today to Base Experiments. You're here with your host, Raven and
Chase.
Oh, okay. Today our subject is oxidation/thermodynamics. You know what? You know what that means? You know what that means.
Basically, we're going to put a gummy bear into some molten potassium chlorate, aka it's hot and liquid. We're starting now. This means we're starting.
Here's a more technical description. This is oxidation of sugar or a gummy bear. This demonstration illustrates the amount of energy available in the carbohydrates, such as sugar or the candy, gummy bear. So there you go. You know, that's a good description. For this process, we were going to need a certain amount of items as a Bunsen burner.
Let's take a technical time out. I'm tired of all this technical stuff. I'm going to lay it straight and tell you what you need to hear.
You want the mic?
Thank you.
Mm-hmm.
So basically what we did was we put 15 grams of potassium chlorate into a test tube. We plugged in the Bunsen burner. We turned the gas on.
You want to start a good flame. You don't want it like full on
Technical
blast.
timeout. So we did the flint and steel, and we pop, lighted that mug. Then, once the potassium had become into a liquid state, the potassium chlorate, we picked it up with our test tube holder.
Tongs.
Technical timeout. And we took it over to the clamp, the test tube clamp. We clamped it in, and we were just like, boop. There goes the gummy bear. The gummy bear went in, and it exploded everywhere up in this test tube, and it got insane. So after the experiment was over, we took it out of the clamp. We did all that. We cleaned it out. We made sure to pick up our lab and fix it back the right way,
all right,
as you always should.
Let me just say. First, you will need. We use what? 15 grams of potassium chlorate.
You know it.
And we need a burner because we need to heat up the potassium chlorate for it to activate the when you drop the gummy bear in.
The Bunsen burner.
You'll need a spatula to help stir up because when it's warming up, the potassium chlorate's warming up. It's going to be in a molten form. We got to shake it or stir it up. You'll need a 15 milliliter beaker, and then a watch glass. Also,
a gas supplement. You're going to need something to put some gas into the Bunsen burner. Otherwise,
you also need, yes,
it's not a Bunsen burner.
You need gas for fire. Yes, you do. You also need a flint.
Flint and steel. You need a fume hood because the fumes can be toxic.
You also want to wear...
And you don't want to die.
Yes. You also want to wear goggles during this, just in case.
And gloves, because the potassium chlorate is a very dangerous chemical. And we don't want anything to happen to you, especially you.
Wade Gilman.
I'm looking at you, Wade Gilman.
Wade Gilman's second
Brown.
Period class. We're looking at you.
Rob Clairday, Kenneth Moore. I'm looking at you, telling you to be safe.
I see you too, Cyril. I see you too.
Adrian, what up?
All right, we're back. We're back. And then material. Okay, so you have those basic materials, and then of course you'll need a gummy bear or a sugary candy, anything that has sugar, the glucose.
Gummy worms could work if you want to use the kind that has the sourness on it.
Yes,
you can use those if you want to get insane.
You do, you will. And tongs to carry the test tube because you will have to heat it up.
It's actually called a, if I may, a test tube holder. Tongs. It's rounded at the end, so you can fit it around the test tube.
And you'll need a ring stand and a test tube clamp to hold the hot test tube in when you drop in the gummy bear because you're not going to want to hold the test tube during that.
Right. And then once this is all over, after you used all that, make sure you wait and let the test tube cool down.
Yes.
Okay. Let the
experiment
finish.
You learned the hard way. Safety announcement. We're ready? Potassium chlorate.
It's dangerous.
It's an extremely strong oxidizer.
It can kill you.
Goggles and proper protective. Sorry, I'm slurring here. I'm so excited. So excited. Equipment should be worn while performing this experiment.
Some gloves.
Also, experiment in the hood. We threw it in there.
We threw it in that flame hood. You know what's up. You know what's up with that fume hood.
You want to keep all flammable or like
that fume fog hood.
Materials clear of this reaction because it's pretty reactive.
You don't want to pour some gas into this Bunsen burner because you will die. Make sure no flammable objects are around you.
Also,
Bunsen burners can burn you. They get up to 14,000 degrees.
Yes, you want to wear a heat protecting glove when you get that test tube, or you can let it cool.
Safest option, let it cool.
Safest option.
Don't just...
Disposal!
Boom, boom, boom. You can pour this down the sink. It's a sink-safe material.
Okay, you're going to allow the test tube and the reaction products to cool. You're going to soak it in water.
Put some water in that.
Scrub to remove residue.
Scrubby scrub.
Alright?
You can put some of that Alcock stuff in there. And just
listen, residue, don't even need that. Residue can be flushed down the drain with water. It's already done reacting. It won't harm anything. Just
you want to dry it out with some paper towels, and then you want to hang that mug up on one of those drying racks.
Test tube drying racks.
Boom. Done.
Thank you for watching, and now here is a feature. This is Phil Fry, the chem guy. He's starring in our show, and he will talk about the equations and the reactions coming from our experiment. Also, stay tuned. We have a video of the experiment live and ready just for you watchers. Okay. One, two.
Do we have to close this?
No. I know, it's for mine.
Are we filming? Are we on? Alright, this is Phil Fry, the chem guy. I know what you're thinking. That's just Raven's dad standing in his kitchen in a cheap shirt. You would be wrong, and that would be an assumption, and in chemistry we don't make assumptions. This only looks like a kitchen because it's my test lab where I'm studying things like potatoes and lettuce and also potassium and the effects it has on gummy bears and such things. Right here, this is what you need to know. This is what's important. Study it, learn it, know it. Right here, up front, okay? I got it written down, so we're going to talk about it. Quick discussion. The thermal decomposition of potassium chloride produces potassium chloride in excess of oxygen with fission to ignite gummy bear. The heat produces continues to decompose potassium and result in a very rapid combustion reaction. I hope you have that all down because there will be a test later. This is Phil Nye, the chemistry guy. I got things to do like get my other kid to basketball practice. So it's on you as kids to study, learn it, know it, and do something with it.
All right, how about that live reaction right there, live for you in Mr. Gilman's room? And how about Phil Fry? Cool guy, huh? Yeah, he is. Listen, if you didn't catch what he said, I'll also give you a slowed down version. He said, the thermal decomposition of the potassium chlorate produces potassium chloride with an excess, not access, we ain't trying to get anywhere.
Access cable.
Excess of oxygen, which is sufficient to ignite the gummy bear, as you've seen. Very explosive, am I right? The heat produced, which it did produce heat, as you may not, you can't tell, there's steam. You guys ain't stupid. All right.
It's hot. I grabbed it.
The heat produced continues to decompose the potassium chlorate, resulting in a very rapid combustion reaction. And as you should have seen, the reactions, or you might see after this video. I don't know how the editing's gonna go, but
do it yourself. Try the experiment.
Thank you for watching.
If you're asking if it would be dumb to do the experiment, you're dumb for asking yourself that.
Actually, Chase, give us some few questions. What are like some what would people ask?
If I upped the quantities and the amount of gummy bears and maybe some
the size of the gummy bear,
right.
Like the gummy worm.
Would the experiment be bigger?
Of course. I think if you added a bigger gummy bear, you would also need to add more potassium chlorate because,
True, because it might not react as much as it did.
or
with
as
us.
long, or completely break down the sugar.
Right, correct, and
You'd
get
have
a
to-
good reaction.
We would have to experiment and find that out. Second question.
Let's say I was to go ask my chemistry teacher, can I check out potassium chlorate by itself, take it home, and blow up a gummy bear? He would say,
No, you cannot, Chase Level, because you know why? You're an idiot.
it'll blow up.
just kidding.
You idiot, it's toxic.
That's
Idiot.
Wade Gilman form. But the real thing is you can. It's extremely dangerous. It's extremely high oxidizer. It is to your skin. Breathing it in, it's just very.
It
needs to
can
be-
hurt. That's why
yes.
we use the fume hood.
It
That
needs to be
keeps
in a
away.
safe, contained environment.
Right.
All right, I think that's it for our little segment.
That was only 2 questions, and the producer said we gotta have 3.
Oh, 3. Okay.
If you had to guess the color of Wade Gilman's eyes, what would it be?
Green.
Green. Wade Gilman's eyes are green.
Okay. Third, real scientific question. Ready for this?
I'm ready.
Listen up. This is the question.
Listen up.
Would the color of the gummy bear change the color of the flame given off? Think about it. We'd have to experiment and find out, right?
Wrong. It would not change. The flame does not depict the color of the gummy
You're
bear.
exactly right.
The gummy bear is dyed to look that
So
way.
that has nothing to do with the flame.
So it would look exactly the same. You could do it with an upside down left right, up down left right.
Polka
Pink
dotted.
gummy bear, and it would look.
It's
it
because
would do
it's
the same.
it's reacting with the sugar, not the dye.
Right.
Awesome question, am I right? Peace out from,
GGN News Network. It's your host with the most.
you know,
Finding Nemo, aka Nemo candy bars.
Alright, that's it.
All right, let's clean up these lights. Or let me.
Okay, let me edit.